Hi there, this is Coach Suiso, and welcome to part 2 of the lesson 2 in chemical reactions. This part 2 is going to be focused on writing the chemical formula equations from words. So in order to do this, you're going to need to know these things here. You're going to need to know how to write formulas, i.e. nomenclature. So if you have forgotten your nomenclature from October, I would recommend going back, watching that video again, redoing the practices. You're going to need to know the physical states of elements at STP. Remember, most metals are solids, except for mercury, that's a liquid. Noble gases are gases. Most of the diatomic elements are gases. And then sulfur and phosphorus are solids. So you are going to have to memorize those physical states. You're going to have to know how to indicate the physical states. So gas, solid, liquid, or aqueous. That's from lesson 1 of this unit. You're going to have to know how to balance chemical equations. That's from also lesson 1 of this unit. And you're going to have to recall the diatomic elements. Remember, those are iodine, bromine, chlorine, fluorine, oxygen, nitrogen, and hydrogen. Those all have to be, when they're by themselves, have to be 2 of them. Okay, I bring clay for our new hut, in case you forgot what they are. So some things we are going to assume, unless indicated otherwise. All reactions are going to be at STP, so you don't have to worry about something being in a different state of matter. You're going to always assume that water is a liquid. If it says water, it's L, except for in combustion. So think about a fire. When water is released as a product of combustion in a fire, it's a gas. It's the steam that's coming off that particular reaction. It's not, you don't have water that comes flying out of a fire. So think about that when you're dealing with combustion. And the last thing we're going to assume is that all acids are in aqueous solution. So if you have an acid, hydrochloric acid, sulfuric acid, whatever the case may be, it's always going to be AQ. It is always in water. All right, we got 2 examples, so let's try this out. All you are doing here is essentially translating. You are taking the word equation and you are putting it into the actual chemical reaction equation. You are not having to predict the products yet. We're going to be predicting the products in lessons 3, 4, and 5. So this is simply translating. All this is nomenclature, but like exemplified to a slightly higher level. That's it. All right, here we go. It says solid sodium metal reacts with water to produce aqueous sodium hydroxide and hydrogen gas. So we are taking that and we are translating it. So I just start left to right. Solid sodium metal is going to be sodium, and it's going to be a solid because it tells me that in my equation. It's reacting with water. So reacting with is a plus sign and then H2O. Remember, we are assuming that H2O is always a liquid unless told otherwise. To produce means we have the arrow. Then we have aqueous sodium hydroxide. So you have to know what sodium hydroxide is in order to be able to do this. You've got to know your nomenclature. You have to know your polyatomic ions. If you don't know those things, that's why we quizzed on them so often, you need to go back and restudy that blue sheet. You need to restudy that unit. But sodium hydroxide is NaOH. It's aqueous, as it says in my word problem. And then hydrogen gas. Hydrogen is a diatomic. You cannot just leave hydrogen like that. It has to be H2, and then it's a gas. Now, real quick, before I balance this, I'm going to highlight it to kind of show you where everything was. So we had solid sodium metal. That's that. Then we had reacts with. That's my plus sign. Then we have water, which is, remember, always a liquid. Then we have to produce, which is my arrow. Then we have aqueous sodium hydroxide, which is right here. And, which is a plus sign. And hydrogen gas is my last piece. So you can see how every single thing that I put into that particular chemical reaction came directly from my word equation. All I'm doing is translating. But the last thing that I need to do is I need to go through and put my balancing in there. So I'm going to go ahead and erase this. And I don't want to erase the words. I only want to erase the highlighting. There we go. Let's go ahead and balance it. We've got 1 sodium on the left, 1 sodium on the right. Then I've got this H2O. H2O is really hard to balance. Remember that trick from lesson 1. Break H2O into HOH. It's going to make your life a little bit easier. So I'm going to make it HOH. So I've got 1 hydrogen here, 2 hydrogens here. So I'm going to put a 2 right here. And then I've got 2 hydroxides, 1 hydroxide. So I need to put a 2 right here, which then adds 2 sodium. So I got to go back and put a 2 right there. And then we are balanced. And that's it. Let's try one more example. We have 1 molar lithium hydroxide with 2 molar phosphoric acid reacts to produce a solution of lithium phosphate and water. Remember when I was talking about aqueous in lesson 1, and I talked about there's different vocabulary words that I might use to describe when something is aqueous, and one of those was using the molarity as a way of defining that it's aqueous. Remember, molarity is concentration. So when you see this right here, that just means it's aqueous. That's just a fancy way of saying that it's a solution. When we get into the solutions unit in March, we will actually use that number. But for now, you don't need to know what that number does. All you need to know about it is that it's telling you it's aqueous. So we've got lithium hydroxide, which is LiOH. And we know because of that 1.0 molar that it's aqueous. It's going to react with 2 molar phosphoric acid. You need to know your phosphoric acid. That came from hydrogen phosphate, which is H3PO4. Make sure you know your polyatomics. We know it's aqueous because of that 2 molar. That 2 molar there does not mean that I put a 2 right here. It's not telling me I have 2 moles of it. It's telling me its concentration is 2 molar. It's basically telling me that since it's in water, I've got 2 moles of the acid in every 1 liter of water. That's what it's telling me. So basically it's giving me this AQ. Do not put a 2 there just because it's 2 molar. And then it reacts to produce a solution of lithium phosphate. So lithium phosphate is going to be Li3PO4. And it's a solution, so we know it's aqueous. And water, which is always a liquid. If, when you're building this out, you need to stop and do the scratch work for making the nomenclature, go ahead and do that. For example, if you got to lithium phosphate and you weren't able to just write it out the way I just did, and you have to do this, lithium is +1, phosphate's PO4 3 negative, crisscross down, Li3, PO4, that is perfectly fine. Make sure you do take the time to do the chicken scratch and do the work with the nomenclature if you're not 100% confident, because then this is correct up here. And that's what you really need to have done right. So don't worry about doing the chicken scratch if you're not 100% confident with that nomenclature. Take the time to do it. It'll always pay off in the end. All right, my last step. I need to check. I've got all my pieces here. I've got all my states of matter, which is fantastic. The only thing I need to make sure I check now is my balancing. So I have 1 lithium on the left, 3 lithiums on the right. So I'm going to put a 3 right here. Then I have 3 OHs. Remember, it's easier to make H2O, write it as HOH to balance it. So I've got 3 OHs over here, 1 OH over here. So I'm going to put a 3. Then I've got 3 hydrogens. So we're set. And then I've got 1 phosphate, and we are balanced. All right, that concludes part 2 of lesson 2 on reactions. Hopefully you've taken high quality in-depth notes. If you have any questions, jot them down, and you will do the practice 2, which is in your packet following this lecture. Let me know if you have any questions, and I'll see you soon.